All right, so in this video, we're going to look at the procedure for solving a rational equation. So let's start with our equation. Now, the first thing that you're going to do, if you have any quadratic terms, what you want to do is you want to try to factor your denominators to make sure that you can find a common denominator in order to solve your problem. Now, first thing is we're going to try to factor this. The two on the left are linear, so we don't have to worry about those right now. What we want to do is factor this quadratic. Now, as is often the case with these problems, you are going to often have factors on one side that are also factors on the other side. Otherwise, the problem can get very complicated very quickly. And it turns out that if you do the factoring on this, factors of 8 that have a difference of 2 are going to be 4 and 2. And you are going to need the 4 to be larger so that when you add minus 4x plus 2x, you get a negative 2x left over. So this is how this factors. They are the same factors that are on the other side of the equation. Again, this is a common thing that will happen in the textbook type problem. All right, so now that we have all of the denominators factored, we can see that the common denominator for the problem is going to be 4x, x minus 4, and x plus 2. So what we're going to do is we're going to, in order to proceed, we're going to clear the denominators. And in order to do that, we could try to find common denominators on the left side and then clear the denominators, but it's a little bit easier, I think, just to go ahead straight to clearing the denominators. So we're going to take our problem, and essentially what we're going to do is for every one of these terms, we're going to multiply by the common denominator. So x minus 4, x plus 2. And then on this side of the equation, x minus 4, x plus 2. And then on this side of the equation, again, what we're essentially doing is we're multiplying both sides of the equation by the same thing. And you're allowed to do that in algebra. And then on the left side here, what we've done is we've distributed, because we have two terms on that side. So we can't only multiply one term, we have to multiply both terms by the same thing. So all of the terms in the expression are multiplied by the same number. So it's like if you have a 1/3 as your common fraction, you multiply everything by 3, and then, where you have denominators, things will cancel, and where you don't have denominators or only partial denominators, things won't cancel. So in this case, when we multiply on this side of the equation, some things are going to cancel, at least partially. So this denominator is going to cancel with this factor. And this denominator is going to cancel with this factor. And on this side of the equation, both factors are going to cancel with the denominator. And so what we're going to be left with is 4 times the factor that didn't cancel, and then 2 times the factor that didn't cancel. And then on the right side, since both the factors in the denominator canceled, we're just left with 30. Now we have a linear equation. So now what we're going to do is we're going to distribute and then solve for x. So in the first parentheses, I'm going to distribute the 4 and get 4x minus 16. And then in the second parentheses, 2x plus 4 is equal to 30. And then if I combine my like terms on the left, I'm going to get 6x, and negative 16 plus 4 is going to be minus 12, is equal to 30. And then I'm going to add 12 to both sides so that I can cancel the 12 on the left. And that is going to give me 6x is equal to 42. And then if I divide everything by 6, again, this is basically just the reverse of what we did before. We multiplied everything on both sides by the same thing. Here, we're dividing everything on both sides by the same thing. 42 over 6 is 7. Now, anytime you have a rational problem, you have to check with the original problem, not only to make sure that, in fact, this is the correct solution, but also to make sure that the value you found doesn't end up dividing by 0. So when you do rational problems like this, you can sometimes get extraneous solutions, not only when you have multiple solutions, but just in general. So you could end up with a situation where the algebra all gives you, let's say, -2, and then you put that into the original problem and you get division by 0. And so then that actually isn't a solution to the problem at all. You can get some of these problems where there is, in fact, no solution because the solution should actually be where you're dividing by 0. So you do have to double check that. Now, given that our denominators are going to be 0 when x is 4 and x is -2, then as long as we didn't make any algebra mistakes, this should be okay. But again, we want to go back to the original problem and verify that that is in fact the case. So again, always the original problem, not some simplified version, because if you make a mistake before that stage in the problem, then you will not be able to find your error. So here's our original problem, and our solution was 7. So let's put in our 7 everywhere. All right. So now if we simplify our fractions, our denominators, this is going to give us 7 plus 2 is 9, and 7 minus 4 is 3. This is going to give me 7 squared is 49, and 7 times 2 is going to give me 14. And then if I simplify this denominator a little bit more, 49 minus 14 minus 8 is going to give me 27. Now, remember, we're not sure if this is in fact true yet, so stick in those question marks. Now, on the left side, we're going to need to find a common denominator, which is going to be 27. So 4 over 9, I need to increase this by 3 to get to 27. So I'm going to multiply by 3 over 3. And then, and this is, we could simplify, make a common denominator of 9 and then simplify the right side of the equation. But since I have 27 and 9 and 3 equal 27, I'm just going to make everything 27. So 2 times 3, to get 3 to be 27, I need to multiply by 9. So my denominator will be 27, and I'm going to multiply my numerators also. So I'm going to get 12 over 27 and 18 over 27. And is that 30 over 27? If I add 12 and 18, I am going to get 30 over 27. So that checks out. That is, x equals 7 is a solution to my rational equation.